In this lesson, we'll talk about a few more common yet relatively simple subjects in web development. Specifically, we'll discuss how to send emails, execute tasks based on a certain schedule. We'll see an example of a view template framework, and we'll see how to deploy Java web applications to an application server. Email, especially sending email, is a fairly important function for web applications. For example, when you order something from an online retailer like Amazon, you'll get at least 3 email notifications. One when the order is placed, one when the credit card is charged, and one when the order is shipped. And of course, there are also many other places where you may want to send emails. And in particular, almost all web applications that require user login provide some kind of password reset function through email. Without that, your site administrators will spend all their time dealing with resetting passwords. Like most of the things we cover in bits and pieces of web programming, once you understand how email works, it's quite easy to use it in an application. This picture shows how email gets from the sender to the receiver. Suppose here we have a user A who wants to send an email to user B. And let's say user B's email address is johndoe@hotmail.com. So user A would write up the email on his or her computer here and click a send button. The email will be sent to this email server, which is configured as the outgoing email server on user A's computer. Once this server receives the email, it will examine the host or domain part of the email address. In this case, it's hotmail.com. It will do a DNS lookup and find the email server that handles the emails sent to the hotmail.com domain. Once it gets the address of that email server, it will send the email to that server. And the email will then be stored on this server. When user B wants to check his email client software will connect him to this server, which is configured as the incoming email server on user B's computer, and retrieve the email from this server to user B's computer, so user B can now read the email. There are 3 email protocols involved in this process: SMTP, or Simple Mail Transport Protocol, which is used here, and here, and either IMAP, the Internet Message Access Protocol, or POP, the Post Office Protocol, which is used here to retrieve the email from the incoming email server. So now we know how email works. We can see that sending emails should be fairly easy. All we need to do is to create an email and send it over to an outgoing email server, which is sometimes also called an SMTP server, and the server will take care of the rest. So from an application developer's perspective, all we need to take care of is this part. The library to use to send emails in Java is called Java Mail. No surprise there. So let's see an example of doing this. First, we need to include the Java Mail library, and it's this dependency from javax.mail. This is the group ID, and the artifact ID is mail. So let's first run this and make sure it works. Okay. So I'm running this project, and if we look at the web.xml file, we can see that I have configured email.html as my welcome file, and this is why when we run this project, this page is automatically displayed. And the email.xml, as we can see, is a regular HTML page. It's not even a JSP. There's no JSP or Java elements in the page. It's just plain HTML. There's a form, and there are a few fields from to subject content, which looks like this. And if we fill out this form and click send, it will submit this form to this URL email using a post request. And if we look at the code, here is a simple servlet, and this servlet handles the email URL, and in the doPost method, which is a method that's going to handle the post request, we get 4 request parameters from to subject content, which corresponds to the 4 fields here, and then we create a message, we send the message. Now if you look at the code, there are only a few lines of code that are important. Here, these 3 lines will create a connection between the client and the email server, and then this line, which creates an email message object, and then this line, which will send the email message to the server, and that's more or less it. Now, in terms of setting up a server, I have 2 guides on how to set up a local server for testing purpose. One is for setting up a server on Windows computer, and the one we use is called HMail server. It's a free email server implementation that implements not just SMTP protocol, but also IMAP and POP protocol. So you can configure this server as both the incoming server and the outgoing server. And on Linux, there's an email server called Postfix, which is widely used, and there's some instructions on how to set up that on Linux here. So I'm not going through the steps to setting them up. I already set it up, HMail server on my local computer. So here, let's look at these 3 lines, which I put it here. These 3 lines, as I mentioned, creates a connection between the client and the server. And to create that connection, obviously, we need to specify where that server is. And this is what this property means. It means that we have to give the hostname or IP address to the SMTP server or the outgoing server. And in my case, that one is on my local computer, so the host name is localhost. And sometimes you may also need to put in username password here, but my local server is configured in the way that it doesn't require username password, so all I need is just a host name. And then we need to create a message object, and then we use whatever user submitted in the form to populate that message object, where here we set the from address, here we set the to address, and we set the subject and content, and then we simply say send, and that's it. If I run this, let's say we set the from address to be johndoe@calstatela.edu. The to address is address on my local server, which is cylison@localhost.localdomain, and we'll say test, and we'll say this is a test message, and we click send, and it's sent. So let's check if it's indeed sent. And indeed, we got this message, which is said this is a test message, and so on. By the way, notice that we can basically fake the from address of anybody. So this message is obviously not sent from johndoe@calstatela.edu. It's sent from this local computer. So what this means is that it's very easy to fake from address. So don't trust all the emails that you see. Okay, so this is how we can do it using the Java Mail library. And just like file uploading and other things, Spring provides a wrapper around the Java Mail library and makes the API even easier to use. Let's try the Spring way of sending email using our previous CS jobs example. So let me stop this one. And let's go to CS jobs. The first thing we do again is to add dependencies, and to send emails in Spring we need a Spring library called a Spring dependency called Spring Context Support, which is somewhat a weird name. And it's Spring Context Support. So we'll choose 4.1.6 so that it's consistent with all the other Spring dependencies. And this one is a wrapper around some additional libraries. And to send email, we need the actual email library, which is Java Mail. And let's get Java Mail, which is this one. So let's get the 1.4.7. This one seems to be a beta release B01, so let's get the production release here. Okay, so once we have the dependencies, then we need to declare a mail sender bin, which is Spring's way of sending emails, of course. And again, let's just grab the one in CSLS2 so we don't have to remember what that mail sender bin is called. Okay, it's here. And let's put it here. Okay, so the class is actually called Java Mail Sender Implementation. But like I said, if you have an example you can copy over, you don't really have to remember the exact name. And for properties, the host is the name or IP address of the SMTP server. And for us, that's localhost. We can specify username password, but like I said, my local server does not require username password, so we can skip that. And so once we have this bin, we can then use it in our code. And let's quickly create a controller for that. Okay. So I'm going to create a controller called email controller. It's of course a controller, and it will use the private mail sender. It will use the mail sender bin to send out emails, so let's auto-var that one. And just like our previous email servlet, we are going to handle both get and we are going to handle get and post. So for the get part, we'll say email and simply forward the request to the form. Then here is request mapping, and let's map it to email.html, and the method is going to be request method get. Okay, so when a get request comes in, we are going to show the form, and let's grab that form. Where is it? Here. So copy and then paste. Okay, because of our view resolver, it always resolve to JSP, and so let's change this one to email.jsp. Right, so this will display the form, and then of course we want to send email. So in post, we'll get the request parameters. The request parameters here are from, to, subject, and content. So we'll say request param from, and okay, so from and to, and subject, and content. Okay, so we have our request parameters, and the next thing to do is to create a message object that we can send out. Spring has its own message class. In fact, it has two. One is called simple mail message, and the other one is called my mail message. And the simple mail message is the easier one to use, but as the name suggests, it has some limitations. In particular, you cannot add attachment to it, and it does not support any special character encoding. But that's enough for us. Let's say simple. What is it called? Simple mail message. Okay. So it's simple mail message. And then we can say message set from. So we set the from address. Message set to. We set the to address. And the message set subject. And the message set content. It's not set called content. Oh, it's called text. So we set text, and then we just use the mail sender to send it out. We say mail sender send, and that should be it. So if you compare this code to the servlet code, which is here, you can see that by using the Spring wrapper mail sender, the code is simplified further. So all the configuration about the email server is outside the application code now, and also for from and to addresses, we can simply use strings instead of converting them to internet address and so on. So it's more or less the same thing, but the API is simplified even further. So let's try this and see if it works. Okay, we go to email.html. We see the form. We say jumbo@calstatela.edu, cysum@localhost local domain, test2. This one is from Spring, and sent. Expected CSRF token not found. Oh, okay. So if you remember when we talked about security last time, we talked about a security attack called cross-site request forgery attack, and because we are using Spring Security now, we have to do something here, and that something is basically including an additional form field called _CSRF. This one is used to prevent CSRF attack. Let's put that in our email form. So go back, refresh. And yeah, we can see that now we have this field. Let's try again. Django@yahoo.com and cysum@localhost local domain, test2. This one is from Spring, and send. Oh, okay, so need to change the action part of the form. Right now it's lowercase email.html, and while we are there, why don't we do a redirect back to the front page after sending the email. Let's wait until it's restarted. Okay, let's try this again. Email.html, please work this time. Django@gmail.com, cysum@localhost local domain, test2. This one is from Spring. Okay, send. Okay, looks like it's working, and let's check. So Django@gmail.com, this one is from Spring. Okay, it works, of course. Okay, so all in all, sending emails is pretty straightforward, as we can see. And now let's talk about something else, which is scheduled tasks. If you think about it, all the operations we have implemented so far, the operations in your homework assignments and the operations in my examples, like the email operation here, all these operations are driven by user actions, meaning that a user must submit a request to the server, usually by clicking on a link or submitting a form or clicking a button or something. But in any case, there must be a request from the client first. And after the server gets a request, the server will invoke the controller code and perform some operations. But what if we want to perform some operations without any user involvement? For example, an online retailer may send you an email about the items on sale every week. A web forum may send you daily digests containing the topics posted in the forum on each day. You may subscribe to a website to receive periodical newsletters and so on. And beyond the periodic emails, there are also other recurring tasks a web application may need to perform. For example, many large websites perform periodical batch data processing to mine business intelligence and so on. If you think about it, all these operations must be performed automatically and periodically without user involvement. We can't really just put these operations into controllers. So where do we put them? The answer is, of course, we put them in scheduled tasks. Scheduled tasks are supported in Java, and the Spring builds on top of that and provides its own support for task scheduling and execution. In any case, you may find it a bit difficult to read the documentation because task execution involves lots of multi-threading and concurrency issues. With that said, if you understand these three terms, you'll find the documentation a lot easier to understand. The first term is task, which is, of course, the operation you want to perform. The second term is executor, and as you can probably guess, this is the object that is responsible for running your tasks. Executor is the confusing part when you read documentation because there are several different ways to run the tasks. For example, you can use one thread for each task and run them concurrently. This maximizes the usage of system resources, but you may run into some concurrency issues. The opposite is to use one thread to run all the tasks one by one, which is safe but not efficient. You can also use a fixed number of threads called a thread pool to run the tasks. And there are various executors for these different scenarios. The last term is schedule, which is sometimes also called trigger. This is how you specify when the task should be executed. For example, whether it's every 5 minutes or every day at midnight or something more complicated like every first Sunday of each month at 8 a.m. or something like that. In Spring, you'll need a scheduler bean that controls one or more executors and one or more tasks, and each task has a schedule associated with it. There are various ways to configure task scheduling in Spring. The easiest way is to use annotations for tasks and the text from the task namespace. Let's do a quick example and see how it works. Let me stop everything. Actually, let's remove this one. Okay, so we want to first add the task namespace to our application context.xml. By the way, we have two bin configuration files in a Spring project, the servlet one and the one called application context. Generally speaking, anything related to web you would want to put in the servlet one, and anything that's not directly related to web, things like security, things like transaction management, and so on, you put it in application context. Scheduled tasks are not directly related to web, so better place to put it is in application context.xml. So first we add the task namespace. So let's copy and paste this one and change this one to task and task, and then we need to add the XML schema. So this one is task, and this one should say task, and the Spring task, it should be 4.1. So Spring task and transactions and context and beans, they are of the same version, and security is a separate project, so they have their own version. So now we have the task namespace, and then the first thing we do is to add a scheduler. And once we have a scheduler, we need at least one executor. So if you just say executor, by default it's going to create a thread pool based executor, and we specify the pool size to be 5, meaning that this thread pool will have 5 threads in it. Let's close that. And then we need to enable the annotations we are going to use. This is the tag. Okay, so now we have a scheduler, we have an executor, we enable the annotation, and then of course we need to create the actual task. And let's say I create a task called task, and I'm going to put it in the package CS jobs task. And here I'm going to say some task, and I'll say just so this task is going to be simple. We just print out something to see it's actually running, and we'll say this is a scheduled task. Okay, we need to make this class a bin so Spring can actually see it, and that means we use the component annotation, and we also need to create a schedule for this task so the scheduler knows when to run it, and that's where we use the scheduled annotation. So if we look at the scheduled annotation API, we can see that there are a number of ways we can specify a schedule. In particular, we can specify a schedule that has a starting time, and then after a fixed delay, it will run the task, or we can schedule a task to be run at a certain fixed rate. But the most flexible way of scheduling things is using something called a cron expression. A cron expression is something that looks like this, which looks pretty simple. It's just a simple string that consists of 6 fields separated by space, and each field represents certain things. The first field represents seconds, which has a range from 0 to 59, and the second field is for minutes, and then third field for hours, and then data months, and data week. For each field, we can specify certain values. It could be a single value, or it could be a set of values separated by comma. For example, this can be a value for a particular field, which consists of several values. We can also specify a range, for example, from 1 to 12 or Monday to Friday. And there's a special symbol for range, which is a star. And the star represents a range from the first to last, depending on the range of that particular field. And furthermore, we can specify range with step. For example, this one says from 1 to 12 at step of 3. So this one is equivalent to 1, 4, 7, 10. So, but this is, as you can see, a more concise way of specifying it, so that you don't have to list every single value. You can specify the range and then the step, and it's the same thing. So, knowing all this, then we can see some examples of cron expressions. For example, this one set the second field to 0, the minutes field to 0, means that this task will be run at 0 minute, 0 second of every hour, every day, every month, every day of week, and so on. So in other words, this task will be run every hour at the beginning of the hour at 0 minute, 0 second of each hour. And this one has 0 for seconds, and then every 10 minutes, right? So this represents a range from 0 to 59, and this one says by step of 10. So this basically means every 10 minutes, and this one says every hour, every day, every month, every weekday. So this represents every 10 minutes. And this one represents every weekday. It's from Monday to Friday at 8 a.m. So the hour is 8, minute is 0, second is 0. And this one says every 1st and 15th of each month. So the day field is 1 and 15, and at 1 a.m. So hour is 1, minute and the second are both 0. So as you can see, cron expression is really flexible and powerful when it comes to specify schedules. And getting back to our example, so let's say we want to run this task every 5 seconds. So that means we'll say every second at step of 5, and then every minute, every hour, every day, every month, and every weekday. Okay, so let's run this, and okay, so 1, 2, 3, 4, 5. Okay, so it's not working, and oh, I think I know why. So this class is under the package csjobs.task. If we look at our bin configuration file, we can see that we have a component scan, but that one only scans csjobs model package. So it doesn't scan this package. Let me add another one here. And let's scan this task package as well. When you use component scan, be a little bit careful. If you have multiple scans, make sure that they don't overlap each other. When you have overlapping component scans, Spring will create two copies of a bin, and that most of the time will cause really weird errors. So make sure that if you have multiple component scans, they scan separate packages and there's no overlap between them. Now let's run this again. Come on. Okay, so it seems to be working. I saw a printout here. Okay, so every 5 seconds. 1, 2, 3, 4, 5. Yeah, so it's working. And this task is being run every 5 seconds without any user input. We don't have to send a request to the server and so on. So this is pretty much it regarding scheduled tasks. It's a pretty useful thing to do, and with Spring it's also fairly easy to do, as long as you have some idea of how to write cron expressions. Now let's talk about Apache Tiles. It's a so-called template framework for JSP. If you have used things like master page or Razor in ASP.NET, you know what a template framework is. Personally, I don't quite like Apache Tiles because A, the documentation is really poor, even by open source project standard, and B, feature-wise it's not as good as some modern template frameworks like Razor. With that said, the purpose of talking about here is not so much about using Apache Tiles per se, but to use it as an example to show what a template framework is and why template frameworks are useful. First, let's talk about why we need view templates. Imagine that you have a big application with hundreds of JSPs. Usually each JSP would have a header showing the company banner and a footer that shows a copyright notice and some other information. If you don't use any view templates, whenever there's some changes to the header or the footer, you'll have to manually edit hundreds of JSPs, which is of course quite tedious and error-prone. At this point, you may be thinking, okay, what about JSP include tags? We can create a header.jsp and a footer.jsp and use the JSP include tag to include them in different pages. Well, there are at least two problems. The first is that using include tags breaks HTML syntax. For example, the opening HTML tag would be in the header.jsp and the closing HTML tag would be in the footer.jsp, which creates confusion when people read the code or when tools validate the JSPs. The second problem is that this approach does not work well with complex layouts. For example, suppose we have 3 types of layouts in our application. Some pages just have a header and a footer, and some pages also has a navigation bar here, and some pages also have a login box here. Ideally, we want to have kind of a superclass subclass relationship between, among these layouts. So if this layout is changed, the other two will change automatically. But of course, we cannot do that with include tags. Also notice that because the login box here is inside the header, it needs to be included by the header instead of being included by the main JSP page. But then there's also the headers that do not have the login box, which means that even for simple cases like this, we need to maintain at least two different versions of the header. And that, of course, is not quite ideal. View template frameworks like Apache Tiles are designed to create this type of layouts and apply them to view pages. In Apache Tiles, the layouts are implemented as template pages, which are essentially JSP pages with placeholders. The actual content that can be put into those placeholders can be JSP pages, strings, and other tiles. There's a third component in tiles called definition, which combines templates and content together. Here's a simple example. Suppose we want to create two pages with the same header and footer but different content. Using tiles, we can create a template page with the header and the footer, and a placeholder here, which basically says, please insert an attribute called content here. We can then create two JSPs that contain the actual content without the header and footer. And then we can create a couple of definitions. Notice that each definition combines the template and the actual content together to produce a view. And the name of the definition will be the name of the view. Notice that the final view or the final response that's going to be displayed to the client is a combination of the template and then the content page. Just like other view technologies, Spring supports Apache Tiles through a special view resolver called Tiles View Resolver. And this view resolver will look for tile definitions in one or more XML configuration files here. We're not going to get into details about Apache Tiles. If you are interested, please take a look at the CSNS2 project. So in CSNS2, the template page and things like headers and footers are under the layout folder. So this one is the main template page, which has some placeholders like here and here, and the actual content are under the content folder. So there are a bunch of JSPs, and the definitions are in this XML file called tiles.xml, and you can see that it combines the template page with the actual content page plus additional strings like the strings for titles and so on. So again, check out this example if you are interested, although we're probably not going to use Apache Tiles in this class. As I said earlier, it's an example showing the usage and the usefulness of having a template framework for a large project. Okay, the last subject I want to talk about is how to deploy a Java web application. As shown in this picture, we usually do development on one computer, and when the application is ready, we need to deploy it to a different computer. So how do we do this in an easy and reliable way? Well, we know that a Java web application has a standard directory structure. So one way of doing this is to just upload the files to the corresponding directories. For example, we can upload class files to the webinf classes folder, and we can upload JSP files under application root and so on. And this is, in fact, exactly what we did in CS320. This obviously is not a good way to do deployment because it's fairly tedious to upload a bunch of files. It's easy to miss some files, and during the uploading process, some parts of the application are updated, but some other parts are not, which could lead to all kinds of problems. The right way to deploy an application is to package the whole application into a WAR file or WAR file and deploy it in one shot. I'm not exactly sure how to pronounce WAR, in fact. Sometimes I say WAR file and sometimes I say WAR file because it comes from the same root as tar file and jar file. And the tar file, for example, stands for tape archive, and the jar file is Java archive file, and WAR file is web application archive. So pronounce it whatever way you want, either WAR or WAR. Anyway, it's basically a special jar file that is used to package a web application, so it can be easily distributed and deployed. There are many ways to create WAR files. You can use the command line to jar, but the easier way is to use either Eclipse or Maven. So in Eclipse, for any web application, for example CS jobs, you can select the project and then select export and select the WAR file under web, and then you specify a location, and that's pretty much it. So Eclipse will export the project into a WAR file. You can open it up and look inside. You can see, by the way, that this WAR file is pretty large. It's 20 megabytes, and the source code of this project is only tens of kilobytes. The reason why WAR file is pretty large is because it includes all the libraries, so that you can deploy it anywhere and it will run. Also know that in a WAR file there's no source code. There's no source code folder because the purpose of a WAR file is for distributing the project in a binary form or for deploying the project on a server. So source code is not included in the WAR file, only the class files and other files that are required during operation. So the class files are all there, the JSPs and the library files and so on, but no source code. Another way to create a WAR file is simply to run a Maven package, and if the Maven build process is successful, it will create a WAR file under the target folder of your project folder. So once you have a WAR file, it's relatively easy to deploy, and exactly how depends on what application server you use. For Tomcat, the default setting allows you to simply copy over the WAR file to the web apps folder, and Tomcat will detect it and then unpack the WAR file and load the application. Or another way to do it is using the Tomcat manager application. What you need to do is you need to add a user with the manager GUI role in the Tomcat users configuration file, the file that we mentioned the last time when we talked about form security. And if you have a user manager user like that, and if you also install the manager app, then you can go to Tomcat and log into the manager web app. Why is it so slow? Yeah, the interface will look like this. It will show you all the web applications currently being run on the Tomcat server, and to deploy or to redeploy application, just go down here and see there's a section here called the WAV file to deploy, and you'll pick the WAV file and then click deploy, and what it does is it will upload the WAV file to the application server and deploy it. So it's pretty simple to do. And Tomcat also supports a number of other operations for deployment. In particular, it also supports command line usage of the application manager, using the application manager from command line instead of using a GUI like this, and so on. So check out the documentation if you are interested. So that is the end of this lesson.